Good evening, everyone. So, for emerging technology, we will be studying geographic information system, and for the entire semester, we will be using quantum GIS for our laboratory. So, for week one, this is the outline of our discussion. We will define what GIS is, its fundamental concepts, significance, components, its workflow, types of GIS data, application and evolution of GIS, and the use of GIS in various industries. Okay, so these are the fundamental concepts of GIS. We have the spatial data, layers, and attribute data. So spatial data, no, it is the information intricately tied to specific Earth locations, such as coordinates, addresses, or landmarks, constitutes the foundational bedrock of GIS. This comprehensive spatial data forms the basis for detailed analysis and visualization. So, dito sa spatial data, ang example nito is yung mga landmarks. For example, sa palengke, sa school, sa mall, no? Sa barangay hall, sa city hall. So those are considered as spatial data, no? Earth locations, coordinates, addresses, or landmarks. Okay? Number two is the layers. Layers, no? These are thematic data sets represented as layers. Usually, they are overlaid in GIS for a nuanced and comprehensive analysis. This layering approach allows for the integration of various features on a map, providing a multi-dimensional understanding of the geographical landscape. So when it comes to GIS, meron siyang mga layers na tinatawag. For example, ang layer ng seafloor, layer ng sea, layer ng water bodies, meron din namang layer ng earth, may layer ng forest, may layer ng trees, may layer ng mountains. So those are examples of layers. Just like kung gumagamit kayo ng Photoshop, meron siyang iba't ibang layers, no, sa right panel niya. So, kung alin ang nasa pinakailalim na layer, yun din yung nasa ilalim na layer sa GIS. For example, ang layer ng seafloor ang nasa ilalim, ang pinakamataas na layer dyan is mountain. So, pagka yung mga layers na yon pinagsama-sama mo, pinagpatong-patong mo, magkakaroon ka ng multi-dimensional understanding of a geographical landscape. Makakaubo ka ng isang environment wherein, for example, meron kang water bodies, meron kang land classification, meron kang mountainous area. So, those are the examples of layers. Okay? The next one is attribute data. Ano naman ang attribute data? So basically, non-spatial information linked to spatial features adds contextual depth to GIS analysis. Whether demographic data, land use classification, or other relevant information, attribute data enhances the complexity and richness of spatial phenomena interpretation. Ngayon, no? So attribute data ibig sabihin nagbibigay siya ng more in-depth meaning for a specific uh, area or location. Kung spatial data is generic sa mall, sa market, sa school, ang attribute data naman nagbibigay pa siya ng mas detailed na definition. For example, sa school, saang school? Sa Wesleyan. Sa mall, saang mall? Sa SM City Cabanatuan. Saang kalsada? Sa Nueva Ecija, Aurora Road. So non-spatial data or attribute data adds contextual depth to GIS analysis. No? For example, uh, uh, land use classification. So residential area in Cabanatuan City, a commercial area in Cagapan City. So those are the attribute data. Okay, so those three are the fundamental concepts of GIS: spatial data, the layers, and the attribute data. So ano ba ang significance ng GIS? So GIS plays a critical role in various fields, for example, in urban planning, environmental science, agriculture, healthcare, and disaster management. No? Tandaan niyo yan, ha? Urban planning, environmental science, agriculture, healthcare, and disaster management. So, doon karaniwan ginagamit ang GIS. No? The adaptability of GIS solutions underscores its significance across a broad spectrum of industries. So, ano ba ang importance ni GIS sa urban planning? No? So, if you're an urban planner and you want to design a rural area into an urban city, for example, kailangan mo ng area or ng location. Ngayon, with the use of GIS, no, ma-identify mo kung saan ang best location ng inyong, for example, residential area, commercial area. No? Example, meron kang ilog sa left side, meron kang mountainous area sa right side, meron ka namang platform sa center or flat area. Sa north mo, meron kang agricultural area. Sa south mo, meron kang possible forest area. So if you're an urban planner with the use of GIS, you can identify where to locate your residential area. Okay? So kung nasa gitna is flat na pwede namang pagtayo ang residential area, so doon ka maglalagay. Ngayon, kung sa west side mo is merong ilog, if you're an urban planner, syempre ang gagawin mo, delikado pala dito, i-adjust ko ng konti or maglagay ako ng konting offset. No? Kung ang distance ng batas is 20 meters away from the river or creek, if you are urban planner, and with the use of data and as for prediction and projections, i-adjust mo pa siya na mas malayo. Gawin mo siyang 30 meters, 50 meters, para yung residential area mo is safe against flooding. On the other hand, kung nasa east side mo naman is mountain area, so mag-a-adjust ka rin sa right side mo. Diba? So that's how GIS works. Alam mo yung landscape or yung palibot ng area mo or the land classification itself para mas maayos yung pagdi-design or pagpaplano mo ng area. For example, dito is urban planning. In the field of disaster management, let us again connect it from the river from the west side and the mountain area in the right side. For example, na center niya is yung isang residential area. Okay? So pagtingin mo sa GIS sa mapa, ay delikado pala sa may bandang east side ng aking residential area. Why? Kasi mountainous area ito, prone ito sa landslide. So ikaw as an urban planner in disaster management, gagawa mo ng paraan kung paano ma-avoid yung landslide and at the same time casualty mo during flood and landslide. So sa mapa makikita mo ay elevated pala tong portion na to. I must place a anong tawag doon, yung mga protective walls, no, to avoid damage to my residential area. Sa may bandang left side naman, nandun yung ilog, no, maglalagay ka ng mga dike, di ba? Para ma-avoid yung erosion during flash flood and ma-avoid din yung pagluwang ng ilog. So in that case, mababawasan yung casualty mo during flood, no? Yung flood susceptibility mo and landslide susceptibility mo, alam mo kung saan. So that's one way of GIS playing an important role in disaster management. In healthcare, for example, again, that's sa scenario natin, no? Meron kang residential area sa gitna and nagkaroon ng COVID. Pag ikaw is isang planner or GIS engineer, ipinpoint mo yung location niya and at the same time, kukunin mo coordinates. As an engineer using GIS, you can now predict or have a projection of the danger zone of COVID. For example, nandun ka sa Westline University, Philippines, and then ida-draft mo or igagraph mo yung 1 kilometer radius ng Wesleyan University, Philippines. So doon sa partners sa healthcare, alam mo yung possible dangers or health risk dun sa area na yun using GIS. So that's how GIS is important in various fields of industries. Okay? Next, these are the components of GIS: the data, the software, hardware, people, and methods. Bakit ba data? Ano bang meron sa data in GIS? So basically, data, no, these are spatial and attribute information forms that foundational core of GIS analysis. This serves as the raw material for all GIS operations. So, ibig sabihin, wala kang data, sa lahat naman aspect ng technology, pag wala kang data, wala kang output. So, dito, ang kinukonsider nating data is yung spatial data and attribute data, the raster and the vector. So, that's one of the components of GIS. Number two is the software. So, in GIS, no, we have various tools or different tools that we can use to uh, to study or learn more about GIS. Software like ArcGIS or QGIS, they provide the means of analysis and visualization, facilitating complex spatial data interpretation. So with the use of this software, doon natin makikita yung layers na tinatawag. Doon natin ma-modify kung ano ang gusto nating makita. Doon natin naayusin kung paano natin ipaplano, for example, ang isang city, ang isang rural area into an urbanized uh, area. So, ang ginagamit natin doon na software ay either ArcGIS or QGIS. Yung Arc is premium, sabihin may bayad, and yung QGIS is free, open source, no? So, usually sa ating emerging tech, ang gagamit natin is QGIS, okay? The third one is hardware. Ano naman ang hardware components ng GIS? Basically, these are the physical equipment. It encompasses computers, GPS devices, and tangible infrastructure for GIS operations. Yung computer, ginagamit syempre para makapaggawa or generate tayo ng maps using quantum GIS. We also have here the GPS devices. Tawag dito, the Garmin, our cell phones, our mobile devices, smartphones. They can capture coordinates. They can use as navigation assets during for example, may pupuntahan ka, pag-geotag mo, pagkuha mo ng pictures, pagkuha mo ng locations. Aside from that, pwede rin tayong gumamit ng drone. Diba? Those are some of the hardware component of GIS. Okay? Computers, smart devices, phones, drones. No? Also, we have the people. So, GIS professionals and users are the interpreters and implementers, bridging the gap between raw data and actionable insights. So, kung walang kukuha ng data, kung walang people, walang kuha ng data. Diba? Kung walang people, walang mag-generate ng information. Kung walang people, walang makapag-solve ng problems when it comes to GIS. No? Kung walang GIS professionals or walang people, how can we interpret, no, the geographic information of a certain area? No? Without implementers, how could this map, no, a map could be proposed, for example, proposed urban area, commercial area, paano natin ito mai-implement kung wala itong mga tao na to? So, kailangan natin ng people sa paggawa ng mga mapa using GIS. And last is the method. It is the procedure or means or ways of handling data, performing analysis and interpretation, no? Establishing the systematic framework guiding GIS operations. So, we have different ways, various methods on how to perform GIS or execute GIS. No? So, iba-iba tayong way kung paano. Meron tayong iba, nagkumukuha tayo ng sources on the ground through ground validation, inspection, or ocular inspection. Iba gumagamit ng method ng data gathering using the internet. No? So those are the components of GIS. And this is the GIS workflow, no? Usually itong sinusunod ng mga professionals or standard way of of GIS, no? So upon kung dumating yung time na specify kayo ng GIS, no? You have your own way of using or performing GIS. But for the meantime, here's the standard way. We have the data collection, the data input, data management, data analysis, and data output. Ano bang data collection? From the word itself, collections of data, on ways on how you collect data. Basically, the gathering of spatial and attribute data from various sources establishes the initial step in the JS workflow. Siyempre, kung wala kang data na hawak, wala kang input. No? So in data collection, either you do perform ground validation, field survey. You can also ask the World Wide Web if they have something for you. No, that's data collection. Number two is data input. Incorporating data into GIS software for analysis from forms a crucial phase, preparing the raw data for further processing. So when you have the data and you think kompleto na ang data mo, you have to import them sa iyong GIS software para lang sa ganon ma-analyze mo at ng system mo kung ano ba yung mga kinolek mong data. And at the same time, ano ba ang pwede na maging output nito, no? So ipa-process mo ito, no? Yung input mo ipa-process ng software, ipa-process mo. So it is the preparation for data management and analysis. Okay, so that's data input. The third one is data management. It is now the organizing and storing data efficiently. No? This ensures easy retrieval and accessibility for subsequent analysis. Ngayon, for example, meron ka ng mga input and sa tingin mo is sobra na to or kulang na. So, ang gagawin mo ngayon, iba-manage mo yung data mo in such a way na you perform organizations of archiving of data, organizations of data in such a way na, for example, itong data na to is for land classification. So-sort out mo yon. Itong area na to is for agricultural classification. So that's data management. It efficiently ensures that you can easily access and retrieve this data for further analysis. Okay? Hindi naman kasi pwedeng kada gawa mo ng map is maghahanap ka ng data. No. Sometimes, mayroon kang tinatawag na mga base maps na kailangan mo talaga in the first place, and some raw data as well na kailangan mo talaga sa paggawa mo ng mapa. For example, roads. Hindi naman pwedeng lagi ka naghahanap ng roads, especially if you are a GIS engineer of specific local government unit. No? Hindi mo naman pwedeng magkakaiba yung iba-iba yung kalsada na ginagamit mo sa yung mapa, no? Unless talagang malawak ang hawak mong area. So that's data management. Organizing, storing, and archiving of data, no? For easy retrieval and easy retrieval and utilization. Okay? Number 4 is data analysis. This naman is the extracting insights and patterns through spatial analysis tools. It constitutes the heart of the GIS workflow. Ngayon, kung meron ka nang na-collect na data, na-input ka na-i-process mo na yung information, yung raw data mo, you can now easily analyze kung ano ba meron sa mga data na ito. For example, meron kang na-collect na data, road network, and then meron kang nakitang data about the classifications of roads. When you say classifications, either concrete, earth, halimbawa, dalawa lang yung classification ng road mo. And in-apply mo ito sa GIS, makikita mo ngayon doon yung area kung saan ba mayroong concrete na road, yung hindi pa konkretong road. At the same time, pag nakita mo yung road na hindi konkreto, susukatin mo yon. As for meron kang halimbawa 1 kilometer length na kalsada, no? And kalahati nun is paved, sa kalahati is unpaved. So mangyari, you can now analyze, no, with the use of the GIS software, meron pa palang remaining 500 meters na hindi nakokongkreto sa part na to. So with that, you can easily analyze ano ba ang pwede kong gawin. So pwede ko itong isubmit sa, for example, DPWH or sa City Engineering Office na sa data ko po na nakuha, ito ang aking analysis. Ito po ang aking nakita. No? Final is the data output. No? It is the way of presenting results through maps, charts, and reports. No? This is the end of the workflow of the GIS that offers tangible and actionable insights. So ngayon, pag nakita mo yung road mo na kalahati is concrete, kalahati is hindi pa, you can now present it use it through maps. No? Mag-offer ka sa mga kinaukulan na meron po akong mapa dito, yung kalahati po dito is paved, sa kalahati is hindi. So ano po ang inyong mga actions na pwedeng gawin in order for this road to have to be 100% paved, no? So that's data output. All in all, these are the workflow. This is the workflow of JS: data collection, data input, data management, data analysis, and data output. So we have types of JS data: the raster and the vector. Raster, representing continuous data such as satellite image or elevation models. Raster data utilizes grid-based format. On the other hand, vector naman, depicting discrete data like roads, boundaries, or land parcels. It utilizes points, lines, and polygons to represent geographical features. Okay, so raster, basically these are images. Vectors, these are the roads, the boundaries, the points, the lines, and the polygons that represents geographical features. Okay, so the applications of GIS, like what I have told you before, in urban planning, agriculture, healthcare, nagagamit dyan ang GIS. Sa urban planning, pwede mong gawin dyan kung maiplat kung saan ba ang best way to create a new road, no, to avoid traffic jams because you are a planner, for example. And when it comes to agriculture, makita mo kung saan ba pwedeng magtanim ng ganitong area based on your survey sa GIS using drones. No? You can also have uh, 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 way to know kung saan ba ang critical area ng pagtatanim kasi nakita mo sa mapa, ano, ay flood prone para dito sa area na to, so hindi ako pwede magtanim dyan, baka masira lang yung aking mga tanim. When it comes to healthcare, like what I have said, napipinpoint kung saan ba may outbreak ng sakit, no? Para nang sa ganun, yung government or your company, the government can have or perform their actionable insights, no? Kung paano maiwasan ba yung outbreak ng sakit. Okay? So those are the applications of urban or of applications of GIS. Okay? So, the evolution of GIS noong 1960s up to 1970s, no? Diyan pumasok yung computerized mapping, no? So, that's 1960s to 1970s, yung computerized mapping na ginagamit for land use planning and natural resource management. Noong 1980s, diyan naman pumasok yung digital GIS, kung saan mas sophisticated ang data na pinag-aaralan and ini-interpret. No? That's 1980s, the emergence of digital GIS. 1990s up to today, up to present, this includes the internet integration, friendly software, and cloud-based GIS and mobile mapping. So ngayon, meron tayong mga ArcWeb, meron din tayong mga cloud-based services, Google Earth, di ba? Example, that's how GIS has evolved, no? Cloud-based GIS, meron tayong mga Google Earth sa phones, mobile mapping. So that's how GIS has evolved through time. Okay, so that ends my presentation for you. But before we end this video, let me share with you a video of about what JS is.
GIS stands for Geographic Information System. Using computer hardware, software, and a ton of raw data, we can explore the fundamental principle of geography, that location is important in people's lives. Using GIS, we can view, understand, question, visualize, and interpret data in visual ways that reveal relationships and patterns, which allows us to make better decisions. For example, a meteorologist might study the paths of hurricanes to predict where and when they might occur in the future. A city planner can choose the best location for a new park or hospital, ensuring that they are built in the place where they're needed the most. GIS is essential to understanding what has happened, what is happening, and what will happen in geographic space. Geographic understanding brings wisdom, and with wisdom, we can make better decisions to create a brighter future.